So many businesses today are just wrestling with the high costs and the sheer complexity of their old IT systems. They're trying to move faster, be more agile, but maintaining a traditional data center, man, that can be a huge drain on resources. So, let's dive into this explainer on Oracle Cloud Infrastructure, or OCI, and see how it was built from the ground up to tackle these exact problems.
So I gotta ask, does this sound familiar? You've got costs that just seem to creep up and up, systems that are a nightmare to manage, and these super long procurement cycles that just kill innovation. This is the reality for so many companies, and it's the big reason we're seeing this massive shift to the cloud.
And you can kind of see how we got here, right? It all starts with those legacy on-premise data centers. Then we see the big move to the cloud. And the foundation for that whole move is something called Infrastructure as a Service, or IaaS. That's where you get all the raw building blocks, like compute, storage, and networking, whenever you need them.
But what do big companies really need when they make this move? I mean, it's not just about renting a few servers. They're looking for true elasticity, the ability to scale up massively, and performance that is rock solid and predictable. They want deep control over everything, but they need to keep costs from just exploding. And that is the really tough nut that OCI was built to crack. This brings us to a really important point, the difference between cloud generations. The first-gen platforms, they were absolutely revolutionary, focusing on virtual machines that ran on shared hardware. But the problem is, when you're sharing, you can get unpredictable performance. So, second-generation platforms like OCI completely changed the game by adding a critical piece to the puzzle: dedicated, single-tenant bare metal servers.
So what in the world is bare metal? Well, it's actually super simple. You get an entire physical server, and it's dedicated only to you. There's no sharing, no virtualization overhead slowing things down, and absolutely no noisy neighbors stealing your processing power or network bandwidth. You get 100% of that machine's performance all to yourself.
And this whole idea of bare metal, it's right at the heart of OCI's foundation. The entire goal is to give you the best of both worlds, the scale and flexibility of the public cloud, but with the control, security, and predictable performance you'd expect from having your own private data center. So how do they actually deliver that kind of performance? Well, one of their key secret weapons is something they call off-box virtualization. See, instead of running the cloud management software on the server itself, which eats up resources and creates a performance tax, OCI moves all that stuff off the server and into the network. And what that means for you is that pretty much 100% of the server's power is dedicated just to your workload.
Okay, so with that super high-performance foundation in place, let's take a quick look at the core building blocks of the OCI platform, and we'll start with compute and storage.
Not all data is created equal, so OCI gives you this whole spectrum of storage options. If you need maximum speed for a demanding database, you've got local NVMe. For data that needs to stick around and scale, there's block volumes. Need shared access across different machines? That's file storage. And for just massive amounts of backups or log data, you've got object storage and the super low-cost archive storage. It's really all about picking the right tool for the right job.
Now let's talk about connecting your own data center to OCI. You've basically got two main options. For your really important, high-volume workloads that need totally predictable performance, there's Fast Connect, which gives you a dedicated private connection. But for less demanding stuff, where cost is the main driver, you can use VPN Connect, which is a secure, encrypted tunnel that just runs over the public internet.
But here's where things get really interesting. When it comes to networking, OCI has a totally different economic model than a lot of other providers. And honestly, this is a point that can have a huge impact on your total cloud bill, especially if you move a lot of data around. And here it is, zero. That's right, OCI charges absolutely nothing for data leaving the cloud, what's often called data egress, when you use that private Fast Connect link. For applications that handle tons of data, this is a total game changer and can save you a massive amount of money compared to other providers.
All right, so we've talked about the architecture and the cool features, but does it actually work in the real world? How does this all translate into real business results? Let's take a look at a few powerful customer stories to see.
First up, we've got a company called Merits. They were really struggling with old hardware, some serious performance issues, and a painfully slow disaster recovery plan for their core Oracle e-business suite. So they decided to just lift and shift that entire environment over to OCI.
And just look at this result.
Their disaster recovery window, which used to be a crippling 72 hours, I mean that's 3 full days of potential downtime, was slashed to just 4 hours on OCI. That is an absolutely massive improvement for business continuity.
Next, let's look at Cisco Tetration. It's a security platform, and they originally tried running on some of the traditional multi-tenant clouds, but they ran right into that classic noisy neighbor problem, which gave them inconsistent performance and high costs for resources they couldn't even really use. So what did they do? They moved their entire platform to OCI bare metal, and the result? A staggering 60 times performance increase compared to the other public clouds they tried. This just hammers home the incredible impact of having those dedicated, isolated resources for your most demanding applications.
And you know, it's not always just about raw horsepower. Take AgroScout, an AI company in the agriculture space. They saw a 5-fold increase in their development velocity. By moving to OCI and using modern tools like containers, they could build, test, and roll out new features way faster than before.
So let's pull all of this together. Let's do a quick summary of the key advantages and the things that really make OCI stand out for big enterprise workloads. At a high level, it really boils down to these 5 pillars. You've got that high predictable performance, which is all driven by that second-gen architecture. You've got superior economics, especially around networking costs. There's a real commitment to openness and avoiding vendor lock-in. And finally, deep tools for enterprise governance and security that's built in from the start.
And of course, you can't forget about Oracle's home field advantage. OCI is just deeply optimized for Oracle's own applications and databases. This means exclusive access to things like the Autonomous Database, full support for high-end systems like Exadata, which are basically these pre-built super-fast database machines, and flexible licensing programs that let you bring your existing software licenses right into the cloud.
Oracle also backs all this up with a pretty unique guarantee, an end-to-end service level agreement, or SLA. And what makes it so unique is that it doesn't just promise your stuff will be up, it also guarantees performance and even manageability, which means you're guaranteed to be able to actually interact with and manage the service consistently.
And this isn't just talk. It's backed by some serious numbers. For its flagship autonomous database, Oracle targets less than 2.5 minutes of total downtime per month. And that includes everything: planned maintenance, unplanned outages, all of it. That is just an incredibly high bar for reliability.
So we'll just leave you with this question to think about. After seeing how a second-generation cloud is built, how would having access to dedicated performance, predictable costs, and that different economic model for networking, how would that truly impact your most critical applications and your ability to innovate for the future? It's definitely something worth thinking about.